Testing again. So any one of you hear me again? Okay, looks like good. I believe some of you may not be able to log on to the Microsoft Team. I think the FGO is currently trying to solve the problem. Okay, so this is our first online learning. So we serve this as a test run first. Okay, then you can have more online lectures in the future. Okay, in case we need to cover our syllabus. By the way, during the presentation, right, please do not disturb the PowerPoint, or you have to mute your speaker, your mic. Otherwise, because this meeting, right, is everyone treated to be the same inside the meeting room in our team system. So you can do whatever as what I did to all of you as well. So you have to be quiet a bit, be quiet, and also turn off your mic, and then you don't scroll your mouse here and there unless you want to type something for the message. So let me share the PowerPoint again. So I will record this our presentation for today, so that you can at least share with your friend, or when your other friend, when he can log in, so he can actually revise, do some revision on what we have been recorded today. Are you able to see the PowerPoint slide? Now I'm sharing the PowerPoint with you all. Okay. So I believe all of you are aware about the announcement made by our Prime Minister yesterday. So our Malaysia has been locked down. So at least they have a control of movement. So you cannot go there and here and there. And also Utah is restricted to not have any face-to-face lecturing or tutorial or lab session. So based on this concern, so for the lecture wise, I think we should be okay. We can conduct our lecture online, and I will record some of the videos to help you, okay, to understand better about your lecture and also your power electronics. For the tutorial wise, I will record the video, demonstrate to you how to solve a problem on the whiteboard as well. Okay? I'll do the separate recording, and then I will upload their solution, okay, on my video on the inside the webber, so that in the future you can actually log in and then you can study by yourself. In case you have any problem, you can always feedback to me by sending an email or even WhatsApp. Okay, so this is our concern. And then for the practical, according to the latest instruction given by the university, the lab will be postponed. Okay, based on the concern, but due to the government said yesterday we have to lock down until the end of this month. So in this case, for those who haven't run your lab experiment, right, I will provide the solution. Okay, means that the expected outcome of the lab experiment to you, so that you still be able to write the report. Okay, I hope you are okay with this at this critical moment. Okay, that means you do not need to construct the circuit and you do not need to collect the data from the experiment, but then I will give you the expected result based on the circuit that we are supposed to construct. Okay, and before this, I will also upload the one video to brief you about the lab experiment too, so that based on this information, you still are able to write the report. Okay, and then you can submit the report as well online. Okay, and then another concern is about the assignment here. For assignment, okay, I know that this is a group assignment, right? So we still need to minimize the risk of contact between among ourselves. So in this case, you don't need to demonstrate, okay, your project demo, okay, at the end of this trimester, but I want you all still work in the group. I want you all to take the video of about 5 minutes to introduce about your design, such as the motor control, okay, your LED driver or other kind of the circuit design, right? Demonstrate how it's work, and then you upload into our Google Share Drive in the future. I will create one share drive for you, all of you, to upload the video. Okay, I hope this is okay to you all. Okay, so when you want to submit the report at time, you submit together with your report. Okay, one report plus attachment of 5 minutes of the video recording to introduce about your project. Okay. Okay. Okay, for this case, right? If you face any problem on the assignment issue, right? Okay, now I can see all of your reply. If you have any problem, you can type in your problem here by clicking the reply button, so that I can answer some of your questions. Okay, for assignment, if you have problem to buy the component, okay, in this case, I am accept if you are doing only the simulation. Okay, only the simulation is okay. So that, but then you still need to explain, okay, the working principle of your circuit through the simulation lah. So you can explain when during the simulation you show the result, how it work, and then from there you explain also in the group as well. Okay, so try to work under limited resources available lah. Okay, as much as possible. Okay, so today I would like to briefly introduce about your to continue about our chapter 4, okay, about the power supplies again. Okay, so as I mentioned earlier, right? So the passive topology of the power supply are based on the buck converter and also the buck push converter to implement, okay, those feedback converter, forward converter, push pull converter, full bridge converter, and so on. Okay, so the reason of this power supply is that the different compared to those buck and buck push converter is because it implemented with the isolating transformer. So the purpose of this transformer is to provide an isolation between the primary and the secondary side. The meaning of the isolation here is refer to the case that it can provide the separate grounding. Okay, separate grounding means primary side you have your own grounding, secondary side you also have your own grounding. So that anything happen at the primary side, such as a lightning strike or other kind of the transient happen at the primary side, it will not propagate into the secondary side, so that your load or your device can be protected under this scenario. This is about the isolation here. And then the second one is, of course, it can provide the multiple outputs. Yeah, this is very important in the power supply design, because they want to minimize the cost and also to fully utilize the transformer function. That's why they are normally implemented to have a multiple output, because in one system they may consist of different output requirement, such as 9 watt to the cooling fan, the 3 watts to the RAM and to the processor, okay, and so on. There are different kind of the output voltage demand. So this is about the multiple outputs requirement. And then the third one is of course is to provide the stepping. Yeah, the stepping means you will be able to control the output voltage by controlling the transformer turns ratio between the primary and the secondary. Okay, this is actually, if you're referring to the buck push converter, right? Compared with this feedback converter or forward converter, you will notice that they were having exactly the same formula, the output voltage formula, except with one additional control of the transformer turns ratio. Okay, so this is the good thing. And the last one, number 4, is about the transformer enable us to control the polarity. Okay, the polarity of the output voltage. This is important because in our circuit design, right, sometimes we need to have a positive input voltage, sometimes we need to have a negative input voltage, such as the one that used inside our op-amp especially. Okay. Okay. Still able to see me? Because my PowerPoint looks like lost already. Still able to hear me, right? Okay. Sometimes this also depends on the bandwidth available in our Utah internet lah, and also the stability of the internet line as well. Okay, I will retry to open the PowerPoint. Okay, so for today discussion, I will start from the feedback converter. Okay, I think I already introduced to you, right, the topology or the basic construction of those power supply design, and the basic introduction about the feedback converter and also the forward converter. And also in our previous lesson, I briefly explained to you the main component available inside the power supply design. Okay, I think this slide, and not this one, maybe come back to the previous one. One of the slides are best to demonstrate the component inside the switching power supply, which is this one. Okay, as you can see from this practical power supply, right? This is one of the most standard way to design your switching power supply. Yeah? So from the input, you can see, right, this is input plug, the code, power code, and then you will see that there must be the EMI filter. Yeah? Because when we deal with the switching device, it contains too much of the harmonics, too much of the switching spike. So we need to have the EMI filter to filter out all those the transient. And after that, we need to have a rectifier. But now rectifier can be very simple. We can make it into IC form. So this bridge rectifier is to convert the AC into the power setting DC. And then later on, in order to generate the smooth input voltage to our converter, we need to have a one piece of the filter capacitor. This is the largest capacitor we can see inside the power supply. Okay, so they were used to filter to provide the smoothen, okay, DC output. And then later on, there will be one piece of the one power IC. It can be MOSFET, BJT, or IGBT that used to control the PWM, okay, the pulse width modulation. Yeah. So the purpose of this PWM is really to control their on-off ratio, so-called the duty cycle, so that the transformer will react. So this transformer, we call it as a switching transformer. It's not the type of those linear transformer. So that you can see, the size is much compact, and the wire size is very small, very fine. Okay, so they need to deal with the switching signal. So at the output side, so we can see that there will be two pieces of the oh, looks like the slide is gone. Okay, no, I will reopen the slide. So again, are you able to see the slide? Sorry. They should be working fine now. Looks like we have a not so stable internet line in Utah here. So I think for our next lesson, I will do it at home lah. So at least I more trusted on my home fiber Wi-Fi. Okay, so let's try first for today's lesson. So everyone have to learn from this hard time. Our university is to ensure that especially those in the year 3 and year 4 are able to graduate this year. This one is very important. So we need to do a lot of adjustment for this trimester. Okay, a lot of adjustment include, maybe this will also affect your final exam as well. So we may rearrange the schedule for the final exam, or maybe to change the exam mode as well. Okay, I'm not very sure yet, as I'm still waiting the instruction from the top management. Okay, by the way, we will still carry on to what we have at the moment. Okay, I'll try to deliver as much as possible to you. You know my pattern, right? I prefer to demonstrate my working on the whiteboard. So this is the first time I just stay on my computer screen and just talk. So this is actually not my stuff. So by the way, we have to accept on this condition. We have to learn. You have to learn. I learn from you, also you learn from me as well. I can give you my experience, but you have to be cooperate, so that we can have a smooth transition from this physical meeting to the online meeting methods. Okay, I spent I spend a few minutes to chit chat with you all first. If you have any questions so far, please type anything on the reply button here. Okay. I cannot write now because my laptop cannot use the touch screen, and if I switch to the whiteboard mode, then it will interfere a lot on the processor. So I don't write first at the moment. Okay, so again I will justify a bit for the tutorial, right? Because of the government have been locked down the whole Malaysia, so I will record, okay, the tutorial showing you how to solve the problem one by one, and later on I will upload the solution on the web, the online system. Okay, so for those who haven't sit for the tutorial 3, right, or tutorial 3 or tutorial 4 about the power supply one, I will record the video, demonstrate to you how to solve the problem one by one. Then I will upload the solution on the web. Okay, the same thing happened to the lab as well. Okay, because we can actually they still have too much of uncertainty. Okay, too much of uncertainty at the moment. So for lab wise, I will also, okay, record one video, demonstrate how the lab actually work. Okay, and then later on I will upload the so-called the default solution, the result that you're supposed to get during the experiment. Then you are using that result to write the report. Then you also need to submit the report. It's just that this time you do not need to construct your own circuit. Result wise will still be the same. Is it okay to all of you? So that you still have the result to write the report and also to submit on time. By the way, for the lab 2, right? I think it will not affect too much because we only have one small portion require you to construct the circuit. So I don't think this will be the issue. So I'll give you the result, because for the lab, right, the part 2 is mainly for explanation only. You do not need to do the experiment. Okay. All right. If no problem, let me come back to our presentation again. Yeah. So just now I show you, right, the process of designing the the switching power supply. So the transformer is to provide, okay, the isolation, the stepping, and also the separate grounding between primary and secondary, right? So at the output side, you see that there will be a Schottky diode. So the purpose of the Schottky diode actually is to provide the rectification, yeah, because in order for the transformer to work properly, you need to use the AC signal. That's why the power IC here is to convert the DC from the capacitor into the pulse setting DC, the pulse, okay, square wave DC, so that the transformer can work. Then it will induce the voltage into the secondary side. Then again, the diode is to rectify the AC back into the DC again. Then after that, there must be the output filter, such as a capacitor and also the inductor, to smoothen the output voltage. So this, and also in order to regulate the output voltage, we need to have a feedback. Okay, This is a must in the good power supply. Without the feedback, you know what happened? Without the feedback, right? If you plug in the different resistor value or different load value, the output voltage will keep changing. Okay, because the output power is fixed. So if you increase the resistor value, the output voltage may drop. So in order to provide a very stable output voltage into your load, we need to have a feedback. Okay, feedback is actually take care by this optocouple or opto isolator. Okay, that provide the feedback to control the PWM. So that when you are changing your resistor value or load, for example, you plug in your handphone into your charger, and later on you plug in the iPad into the same charger. So the iPad and the handphone may have a different input impedance. So if I do not implement the feedback system, the input voltage may be different. So this will affect the stability of your charging process. Okay, so this is the requirement for the feedback. Okay, now I will continue my discussion, okay, to the first type of the most popular power supply, which is based on feedback converter topology. Yeah, feedback. As you know that, right, the feedback converter is based on buck push converter as a passive platform. Okay, the buck push converter. So because of the buck push converter experience the high peak inverse voltage. You know the peak inverse voltage, right? The peak inverse voltage represent the maximum voltage that need to be withstand by the switch when the switch is open circuit that time. Okay, because the PIV, the peak inverse voltage for the buck push converter is double. Okay, as what I demonstrated to you during our last class, the voltage on the switch when the switch is open circuit is the 2 VD, okay, 2 input voltage. So that means the voltage stress is double compared to those buck converter. In another words, because of this high voltage stress, your feedback converter are normally used in the low power application device. Okay, typically is less than 50 watts. Okay, it's popular in the circuit design, but limited to the low power application. This is for the feedback converter. Okay, the reason is because the high reverse voltage stress on the switch. So this slide show you the passive, okay, construction of the feedback converter. Yeah, so basically it can be very simple. So we have a regulated DC input. Yeah, this DC input is from the after the rectifier. So we have an input capacitor to produce the constant input voltage. And later on, the switch actually is to control the duty cycle, or so-called the PWM pulse. Class, you please don't click on the PowerPoint slide, yeah, because everyone actually having the same priority in this meeting room. So if you click on the something, then the thing will change. Okay, the slide is gone, so I will reopen the slide. Looks like the line in Utah here are not really stable because I'm using the Wi-Fi. Okay, so by the way, in this Thursday class, I will use my home Wi-Fi. I hope that it can work much better because my home, I believe, it has a much faster speed. Okay, be cooperative. Please do not, as what your friends say, do not tangan gatal. Don't touch here, don't touch there. Another reason I don't switch into the whiteboard mode is that I know some of you may also tangan really gatal one. You want to write something on the whiteboard, so it will cause the thing to have problem. If you don't believe, right, let me I turn on the whiteboard. Okay, see what happen. Just for a while, just for testing purpose. Where is our whiteboard? I forgot. We're supposed to have a whiteboard function here, but it's okay. Never mind. Okay. Because yesterday we also have a group testing, but when we try to switch into whiteboard mode, so everybody is getting hand kata lah. So everybody want to write, so they draw a lot of Doraemon picture lah, the whatever Naruto lah, One Piece picture inside. So it made the session become very chaos lah. So I don't want to use that first lah. Yeah, I know. Some of you like to draw the Naruto. I like to draw the One Piece as well. I prefer to write to draw the Doraemon. Okay, this is my favorite cartoon. Let me try first. Okay, sorry. Okay, let's come back to our discussion again. Okay, please keep your hand away from the clicking the PowerPoint. So this time we have to learn from each other to be more cooperative, and also how to maximize the effectiveness of delivery mode. Okay, come back to this feedback converter again. So feedback converter, why we call it as a feedback? Actually, very simple, right? When you look at the transformer, okay, look at the dot. Dot is very important as an indicator in your power supply design. So the dot tell you that if the dot is a positive, it happens to be the same at both primary and secondary. If the primary is positive, then the secondary side, the dot there also represent the positive. They will have the same polarity to show you the direction or the polarity of your circuit design. Okay, why we call it as a feedback is because when the switch is on, right? So your transformer, the core here will be energized. When the transformer is energized, but then the diode now is reverse bias, so they will not be able to transmit the energy to output. So by the way, when the switch is off, now the transformer core start to collapse. When they collapse, the energy will supply to the output, and it will fly back to the primary side again. So that's why we call it as a feedback converter. So the feedback is like this. When the switch is on, nothing happen to the output. So the output voltage now will be maintained by the capacitor. Okay, because capacitor is the energy storage device to maintain the output voltage. But then when the switch is off, then now energy will supply to the output. Because when the switch is off, the diode now become forward bias. Then it will supply the energy to the output. Then it will fly back to the input again. So that's why we call it as a feedback converter. So this slide shows you the operating condition of your feedback converter when it is turned on and off. The red color part represents the on active component. Active means it's in on stage. Then the black color one represent their passive component. Okay. The feedback characteristic is that you see the advantage. They use a coupled inductor to act as an isolating transformer and for energy storage component. And then the reason is that they use the transformer to replace the inductor, exactly inductor, in our buck push converter. So in the feedback converter, you do not need to add in another piece of your inductor inside, because the job is being replaced by the transformer itself. So in this case, you can save your cost to buying the expensive inductor. Input and output ground are isolated. This is a must for all kind of the power supply with isolating transformer. Eventually, this is the primary objective of the transformer. It also can provide the voltage step down or step up by controlling the duty cycle. Multiple output is easily implemented. Does not need to separate the output inductor. That means the inductor function is already taken care by the transformer itself. So you don't need to install another separate inductor for this filtering process. So it's best for the low power application. Typically is less than 50 watts typically. Okay. By the way, for the disadvantages is that it has a high output ripple current and high ripple current as well. The reason is that because even though you have the inductor, but this inductor typically is not exactly work as a filter here. So they may not be able to 100% work as a filter compared to those output filter that used in the buck-boost converter. So that's why they have a higher output ripple, okay, especially ripple current. By the way, the ripple current is not the very big issue in the power supply design. The more concern is on the voltage. As long as you have a very stable output voltage, the current wise, it depends on your different load requirement. Okay, so this slide showing you the process to derive the formula for the buck-boost converter. So I think this one I already demonstrated to you during our last viewers class. So the thing I want to show you is that the formula. See, the formula of the output voltage is actually exactly same like a buck-boost converter. Only that it has the extra control by controlling the turns ratio. But please be noted, the N2 to N1 ratio control, right, is considered as an optional function in the transformer, because in a lot of cases the output voltage already can be controlled using the duty cycle. So in a lot of application, they purposely make it to have a N1 equal to N2. That means they do not provide the stepping function. They only want to provide the isolation. Okay, that's why you can see a lot of the power supply, the N2 is equal to N1. That means they don't provide any stepping function. Okay, so this is the first formula for the feedback converter. And also you notice that, right, for the rest of the component, you notice that a lot of similarity to the buck-boost converter, especially the formula for the ripple are exactly the same. Okay, so in this feedback converter, I only want you to remember one more formula, except this output voltage formula, right? It has an extra control. The another formula is the formula for the inductor current. Okay, the inductor, because for the buck-boost converter, the output current is different to the inductor current, so the formula are slightly different. So when you look, okay, let's look at the this formula. Okay, so you got to remember this formula. Yeah, you will notice that, right, the inductor current formula, right, is exactly the same as the formula in the buck-boost converter design without transformer that one. It's the same thing. It's the same thing, except that for the case with the transformer, I have one extra ratio. Okay, the ratio control N2 and N1 squared. This one. So this formula will not be given in the exam. So please remember this formula. You can refer to your buck-boost converter formula as a reference, but you need to add in the N2 to N1 ratio to show that you have extra control about the inductor current. IL represents the inductor current on the transformer. We call it as a mutual inductance current. Okay, because the transformer is a kind of energy storage component as well, so they will be able to store the energy. And then in this case, they will control the current flow as well. So this LM, ILM will determine your operating mode, whether it is operating in the continuous mode or discontinuous mode. One of the methods, I can say, to determine your operating mode of your converter circuit design. Okay, this is only the two formula which are different. One is the output formula with the N2 and 1 ratio. The second one is the inductor current, which also with the N2 to N1 control ratio. Okay? And by the way, LM minimum is also same like a buck push converter, but with also with the N2 to N1 ratio control. Okay, this formula, the L minimum represent the minimum inductor which is I need to ensure my continuous conduction mode operation. The LM minimum. LM itself represent the mutual inductance, means the inductive effect on your transformer, because the transformer is a kind of energy storage component. Okay, the formula same like a buck push converter, except with the N1 to N2 ratio square here. Okay, so this is the concern. Then the rest will be exactly the same like a buck push converter, especially the ripple. You see from here, okay, the ripple voltage, right? The IL maximum is IL plus the ripple divided by 2. So that means the ripple formula are exactly the same. To make it simple, I want to explain like this. The ripple, right, is fully in charge by the capacitor and also inductor only. Such as, for example, the ripple voltage, right? The ripple voltage is fully in charge by the capacitor. So the output capacitor in the feedback converter having the same position and same function as the one in the buck push converter. That's why the formula are exactly the same. The same thing happened to the ripple current as well. Okay, because the ripple current, right, is controlled by the inductor. So because the inductor in the feedback converter are analog or equivalent to the inductor in the buck push converter. So in this case, the formula for the ripple current will also be the same as well. So by this, you'll be able to find the maximum and the minimum inductor current. So this, by referring to the minimum inductor current, right, this is another indicator where you can use to identify your operating mode. Okay, so this is as long as the I minimum is more than 0, I can confident to tell you that, oh, my circuit will be operating in the continuous mode. But if I notice that at any instant my I minimum having the value less than 0, definitely this is referred to the discontinuous mode. Okay, this is some of the scenario about the operating mode available. Okay, let's assume like this. Initially, I have a very simple and light load. Let's say, for example, I plug in the 5 watts, okay, the 5 watt cooling fan, the servo motor fan into the charger port. Okay, normally those 5 watt fan, right, having a very small power consumption. So if I have the very low power consumption, in this case, my controller will control the duty ratio to maintain the output voltage with a small ripple. That means if my load is very light, I only need to turn on the duty cycle for the short period of time. You get my meaning? Okay, I repeat. Let's say I plug in the one very light load device, such as the LED light or such as the 5 watt DC motor into my 5 watt charger, for example. Okay, under the low power demand condition, my duty cycle only need to turn on for a short period of time. Okay, because I are already enough to supply power energy to power my load. So under this condition, okay, I repeat again, if the light load is used, only small amount of energy is required. Meanwhile, switch turn on time is very short. I turn on a while, I turn off long time, and turn off time is longer. So under this condition, the magnetic field energy is quickly discharged into the output capacitor. Yeah, because I only turn on for a short period of time. So the energy that been transferred to transformer is just very little. So that means it will dissipate very fast to the output side. So under this condition, okay, the discontinuous mode occur and only the capacitor is continuous to maintain the output voltage. I hope you understand this statement, yeah, because I only need a very small amount of energy to power my fan, for example. So I can control my duty cycle to turn on for a short period of time. But if I turn on for a short period of time, the amount of the energy being transferred to output side is very little. That means there is the possibility or the period where the energy inside the transformer is fully drained out. So this will cause the circuit to operate in the discontinuous mode. By the way, okay, now I slowly increase my load. Let's say I replace the fan with the higher power motor, for example. Okay, so what happened is that, okay, as the load increase, slowly the circuit operate from the discontinuous to the continuous mode. The circuit operation change from DCM, okay, discontinuous to continuous flux mode if the output power from the circuit increase beyond certain value. This is true because if you increase the load demand, so I need to get more power, more energy to sustain my operation. So in this case, the turn on time of your switch will be longer and longer and longer. So when the switch on time is getting longer, more energy will be transferred into the transformer, then your transformer will be able to maintain their continuous mode. So this is the operating scenario. Okay, normally this will happen for the power supply with the feedback system lah. Okay, because the feedback will be able to monitor your duty cycle. Okay, so in general, for the better control over the output voltage, the discontinuous flux mode of operation is preferred, because if I operate in a discontinuous mode, there will be no excessive current inside the transformer, so it's very easy for me to handle the operation. Okay, it's easier to control because there are no remnant inside the transformer. By the way, if you need the higher power application, then you must go into the discontinuous mode. So by the way, in the industrial point of view, right, in our general application, we always design our circuit into the continuous mode, because the continuous mode can ensure, okay, your circuit can have a sufficient current to your device under any working environment. Okay. So this one is a practical feedback converter. Yeah, you will notice that, right? One of the components that I never discussed before is about the snooper circuit. Actually, the purpose of this snooper circuit, right, is to provide the protection against the switch. The reason is because, right, you see, when the switch is on, your snooper circuit, right, is in the reverse bias mode, so it will be not working at the moment when the switch is on. Okay, but when the switch is off, that time the energy that been stored inside the transformer core, right, will be fed back into the primary core. Okay, then this primary core, right, will serve as a independent energy source. Okay, it will work like an independent energy source. So the voltage that induced back into the primary actually is referred to N1 divided by N2 multiplied with the V out. Okay, I cannot write here. Actually, it's N1 divided by N2 times the V out. Means the feedback voltage from the secondary side. When the switch is off, the secondary side will feed back into the primary side. So this the primary core here will work like an independent source. So if I do not install the so-called the stable circuit, right? So this energy will be hit on my switch, will hit on the switch like a spike or transient or hit on the switch. There is a tendency or the possibility to kill my switch in the long run because it turn on off very fast. So the transformer will generate the spike, the high spike. So they keep kicking on you. Okay, they keep kicking on you. So in the long run, the switch may get spoiled very fast. So the purpose of the neutral circuit here is to provide the path, okay, the path for the energy inside the primary core to be dissipated away through the neutral circuit. So it's something like the freewheeling diode function. Oh, I hope you understand with this, the stable circuit. Normally, this is the mass in most of the power supply design is to provide the protection. Yeah, in the case, if I ask this question in the exam, right? Just explain the purpose of the stable circuit is to provide the protection on the switch, to protect the switch. Because when the switch is turned off, the feedback from the secondary side can have the value of N1 versus N2 multiplied with the V out, which can be very huge. So if I do not install the stable circuit, it may hit on the switch that may kill my switch in the long run. Okay, so this is the main function of this stable circuit. Okay, so do you have any questions so far? Anything you want to ask? Please okay, raise your hand or let me know if you have any idea. Okay, now we open for question first. Anything you want to ask? Okay, please ask here. Okay, this time we have the very so-called the very lenient attendance recordings method this time. Also, the faculty also give the instruction that so this time we have to make it more lenient to your attendance. Okay, so for this week onwards, okay, basically there will be no more attendance basically. Okay, so by the way, you all please join the meeting because this is for your good as well. Okay, so you don't take this as a reason that you don't attend the class or you can simply ignore the lesson because even though we go for online mode, there are still a lot of the tips will be given through my presentation here as well. Okay, so that means because of this virus issue, so there'll be more tips given to you compared to last year during but the tips will be given up on and off during my presentation. Okay, I hope you're okay with this. So we will carry on this kind of the teaching mode. Okay, so as long as the government still declare lockdown, unless the government release the lockdown, then we can come back to our face-to-face lecture. There is a whiteboard. Okay, maybe problem is that I use my laptop to do it. So I only can use a mouse to write. Unless I use the tablet or touchscreen, then I can write properly. Okay, you can try to switch to whiteboard mode and see whether is it working or not. Okay. Which one is whiteboard mode already? I don't see the whiteboard function. I tested yesterday that it worked. Anyone see the whiteboard function? I think that I have to exit this one and then to close the PowerPoint. Then only I can open the whiteboard. I think. Okay. Now let me try out. Okay. So this one is whiteboard, right? Now see, anyone can see the whiteboard. You can try to write on it. Okay, you try first. You can actually, every one of you can try, can write. This is a problem. See, if I switch to whiteboard mode, there'll be a lot of the things will happen. You can see it, but unless you all be cooperative and then we only me to write, then it may be much better. So in a short while, it will be a mess up. Something like a so because this one everyone have the same equality, so everyone can draw, can play, so you can play the game. And also because of this reason, right, they will cause the line to become very unstable as well, because when a lot of people go and do a sketching and drawing, then you will keep me out from a whiteboard. So this one is really not so good. I still finding the way lah. So see how I can demonstrate to you. Okay, because you know my pattern, right? I prefer to show you on the whiteboard, and then I prefer to 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 demonstrate to you on my working on the whiteboard. So I also feel very uncomfortable to just talk only. Yeah, see, it keep me out from the whiteboard. So I just close it. Okay, let you to draw first. Okay, if you want to draw, you can draw first. Yeah, I think this may be one of the solution. Okay. Okay, so because today, right, a lot of your friends are still not able to access to the online system. So I do not want to explain too much. Otherwise, they may miss out too much information. So for today's lesson, I will stop here. Okay, only. By the way, we can still continue to have some testing on the function we have on this Microsoft team, so that you can get more familiar on this system. Who know in the future we may need to stick on this system, okay, until the end of this trimester. So we have to learn so that everyone be familiar with the function inside. How to get into the whiteboard again? Anyone can open the whiteboard? We try the whiteboard. Because at least we can try how to erase the content, how to edit the content, and so on. Which one is the whiteboard function? I don't see the whiteboard function here. Okay, let's go for whiteboard. But then it takes long to load. If I switch to the whiteboard mode, it may be due to the internet problem, or maybe too many people writing on the same time or whatever. So you cause the line to become very unstable. So later I will try to do it at home. Okay. So if the everything is okay, we still can continue on the whiteboard. Then to I have the writing pad at home, so I can write as well. How to erase? Can see I can erase. You all can draw like that. I erase. Okay. Something like a playing hide and seek. Looks like you can play a game here as well. Who play the Clash of Clans? I still play Clash of Clans also. But I don't play those new game such as the PUBG or the kind of the new game. Okay, I have no time for that. I just stick on the one game. Yeah, Apple Pencil is very expensive, but if you use the iPad 6, the iPad 6 and above, you can use the Apple Pen, but you don't buy those original iPad Apple Pen because very expensive. You buy from China, right? One of the brand one, I think I forgot the name, is about 150 ringgit, Malaysian ringgit. And so they also give you a lot of the free software as well. It's a cracked one, but they use their username, then they give you their username and password. You can log on, then you can download through the Google Drive, whatever. So actually that one is very worth because I got a colleague that use the Apple Pen, which is third party one, which is also very good. Okay, very no different to the original one. You mean the China one broke in 1 month? My friend using it for almost 1 year already, but still working very well. The charging, everything, very good. Battery life is also good. They give you the tips, okay, many the pencil tips, many pieces. Okay, so later on, I will record the tutorial, especially the tutorial 4. I will explain on the whiteboard. Then I will record the video, and then I will upload into the web. This is for those who have no chance to attend my class during the last week lesson. Okay, and then I will do the same on the lab demonstration as well. Okay, I will explain the working principle of the lab session, the lab 2, and then I will upload some of the result that you're supposed to get, okay, from the lab experiment, so that you can prepare the lab report without going through the physical setup of the lab experiment. Okay, the result, everything will be the same. So I will explain to you with the working principle and so on, then give you the result so that you can prepare the report. Then you can submit the report according to the schedule as well. I think this is okay with you. Okay, for assignment wise, okay, so I can give you a few options for the assignment. Okay, one is that if you can get the parts, they will be perfect. Okay, they will be perfect, so that you can continue to implement the component, implement the circuit, and then you can, so that after you implement the circuit, you need to take the video, okay, for 5-minute video, so that you submit the report together with the video. I will create one shared drive with you later on, so you just upload your report together with the video into the shared drive. This time we do not need to have the physical product demonstration because of this coronavirus issue. So you just need to record the video, how the things work, and then show your face to show that you have a good teamwork. Okay, so that you all cooperate to work together. That will also contain some mark because it's a teamwork. Okay, this is a case 1. In case 2, if you not able to get the component, you can try to get from the lab by you request from the lab. Okay, maybe one day you send the representative to go to the lab to request for component. If you cannot get the component, you just run any software simulation. Okay, run some simulation. At least you show the working principle on the simulation, and then you can also record the video based on your demonstration on the simulation work. Okay, the lab is still open. It's still open, but they are having control because they need to control the number of students. They do not allow you to conduct the lab in the lab okay, but you still can go in and ask for the component. They still allow that okay, but don't come in the group so you come maybe 1 or 2 is enough. You don't try to avoid any possibility to have a high number of students. Okay, you have to take all the precaution because this can be very serious. If the thing explode then it will become a disaster actually. Even though it will not kill many people, but it will bring a lot of the inconvenience to everybody. This year is a hard year for everybody. It's a hard year. Okay. Yeah, actually based on the government policy, the announcement made by the PM yesterday, all the agency, all the company has to be shut down. Okay, had to be shut down means the close. So unless you have a special request, then you actually can need to get the permission or whatever to the university. So I think you need, when you can come here, but you need to register or whatever to monitor your temperature and so on. Okay. I think from Wednesday onward, everyone is working at home but our video online teaching will carry on as normal. Okay, I will provide more teaching hour. Okay, so that you have more time to interact with me, to raise up your issue and so on, and also to give you more hints on the exam matter. Yeah, I hope everyone okay with this arrangement. Okay, again so if also assignment is because the assignment is a group teamwork. So if you are not able to meet your friend, I understand I'm okay with that. Okay, but then you try to communicate through the WhatsApp group and then try to work virtually You all can make the online meeting such as what we did today. Okay, because now they fully utilize the technology that you will have at the moment. Okay, fully utilized. You can also even put this as a proof as a part of your assignment. Okay, because it shows that you have finding the way to work together. Okay, and so on. Okay, so you can capture the video, the picture as a proof that you all having the online meeting, video conference, and so on, so that I can understand your situation. I totally understand that you all may not be able to work together. Okay, physically meeting may not be a good option. Okay, but you can try to discuss and then distribute the job from one to another. Okay, between among yourself. Maybe one to searching for information, one to deal with circuit design and so on. Okay, work in a group. So I prefer you to have a group between at least of 3 to 6 maximum. You can mix with any background, okay, MH, 3E or any background, it's okay. Because teamwork, you need to work with the different people, different background and so on. This is the way to learn. So this time, our case are slightly different to the previous batch because everyone is going for online this time. Okay. I actually you can show your face here, but I think my camera having the problem, so I cannot show the face. But I think it's not the big issue lah. So I cannot show the face. Some of my face are not so good looking, so I think no point to show you the face also. Okay, so anyone has any problem? You can. You don't need to talk over the mic. You just type the message here. Then I can see your message. Like I'm selling something on the YouTube or selling something on the Facebook. Okay, same thing They go for live streaming. They're selling the cloth the face mask kind of things. A lot of people selling the online products. So any question? I try to control my speed as slow as possible, so that you can have time to catch my point, okay, and to jot down the notes. But in case that you miss out anything, you can type the message or ask me to slow down or control the speed kind of things. Okay, we have to learn from each other. Okay, let's go. If anyone have any problem, please type the message here. If no, then I will stop the meeting for today, this morning session. Okay. I shortened a bit because a lot of you still struggling on how to log into the system yet. Let everyone settle the problem, then can I can discuss more. I can provide more online teaching. Don't worry, okay? We will try to work it out together. Yeah, this session I think is recorded. I think you can still see the recorded video later on. Yeah, you just do at home, okay? You can, as long as you can just make it work or whatever, then record the video, okay? Just record the video. Okay?